Illustrations on integration. Illustration 1. A circular colony of bacteria has a radius of 0.5 centimeters. At distance r from the center of the colony, the density of the bacteria in units of 1 million cells per square centimeter is observed to be B of r equals to 1 minus r square. What is the total number of bacteria in the colony? Assume that the distribution of bacteria is radially symmetric. Since the distribution of bacteria is uniform in the radial direction, we can assume the circular colony to be a collection of an infinite number of rings, whose distance varies from 0 to 0.5 centimeters. Let's consider two rings with radius r and r plus delta r. The number of bacteria delta n in this region is the area between the rings of radius r and r plus delta r multiplied by the density B of r. The area of the ring is pi r plus delta r whole square minus pi r square. If we consider the delta r square to be negligible, the area of the ring approximately comes out to be 2 pi r delta r. Thus, the number of bacteria comes out to be delta n equals to 2 pi r delta r into 1 minus r square. To get the total number of bacteria in the colony, we integrate the overall rings from r equals to 0 to r equals to 0.5, and the thickness delta r becomes dr. On integrating the above function, we get n equals to 2 pi into r square by 2 minus r raised to the power 4 by 4 from 0 to 0.5. On substituting the limits in the above equation, we get n approximately equals to 0.22 pi million per square centimeters. Illustration 2. Calculate the volume of this sphere of radius r using the method of integration. A sphere can be considered as a collection of infinite number of disks, whose center lie along the line passing through the center of the sphere. Since we can divide the sphere into infinite number of disks, we can integrate the volume of individual disks to get the total volume of the sphere. Consider a disk of thickness dx kept at a height x from the center of the sphere. The radius of this disk r is under root r square minus x square. The volume of this disk comes out to be dV equals to the surface area of the disk multiplied by its thickness. Thus, dV equals to pi r square minus x square multiplied by dx. We can integrate all such disks whose height varies from minus r to plus r. Thus, V equals to pi r square x from minus r to r minus pi x cube by 3 from minus r to r. On substituting the limits, we get the volume of the sphere as 4 by 3 pi r cube.